The last little section here is just writing exponential equations. So we've done this with every new function that we've learned where they give us some information and we write the equation. Here the information they're going to give us is two ordered pairs, right? X, Y, X, Y. So we know that exponential functions are in the form y equals a times b to the x. So I'm going to take each equation and I'm going to plug that ordered pair in y equals a times b to the x. So in the first ordered pair, 4 equals a times b squared. Maybe I'll use it in a different color here for the second ordered pair. Would be what? 64 equals a times b to the sixth. And what we're going to do is solve the first equation. We're going to do substitution, basically, right? So if I solve the first equation for a, this is going to be 4 over b squared equals a. And that 4 over b squared is going to be plugged in here. Replace a with 4 over b squared. And if I simplify, I get 64 equals 4b to the fourth. Divide both sides by 4, so b to the fourth is 16. Remember, the base is always positive, so b is 2. If I take that b is 2 and substitute it back in here, 2 squared is 4, and 4 divided by 4 is 1. So a is 1 and b is 2. So y equals 1 times, not 1 times b squared, 1 times 2 to the x. Or just y equals 2 to the x. Which we might have been able to figure that out in our head anyway, right? So the next one here, the ordered pair is 110, and the other ordered pair is 480. So in the first ordered pair, I'm going to say y equals a times b to the x. And in the second ordered pair, y equals a times b to the x, or b to the fourth. So I can solve this for a, so 10, wrong color. So 10 over b equals a, and then that'll get plugged in here, 10 over b. So it's just substitution, really, a times b to the fourth, right? So 80 equals 10 times b cubed, so 8 is b cubed, so b is, right, 2. And then if I plug 2 back in here, 10 divided by 2 is 5. So this equation, y equals a times b to the x. And just be careful, that is not equal to 10 to the x. Don't confuse that, right? Order of operations. This one, these two here are actually a little bit easier because they each go through the ordered pair 0, 1. So I'm going to do it the same way. Y equals a times b to the x. So it's going to be 1 equals a times b to the 0. Well, what's b to the 0? Right, it's 1. So I automatically know that a is 1. When I do this ordered pair, y equals a times b to the x, I have 1/2 equals, 1/5 equals 1, because I already know that the a is 1, times b to the negative 1. So 1/5 is b to the negative 1. Isn't b just 5? So this is y equals 5. 1 times 5 to the x, or just y equals 5 to the x. If you can solve the equation without doing the work, I'm really actually fine with that. It's so much easier with, you can kind of look at this, isn't this, well, we'll just do it. So y equals a times b to the x. So 1 equals a times b to the 0, so a is 1. Once I know that a is 1, for my next one, y 1/16 equals a, which is 1, times b, which I don't know, to the x, which is 2. So what number, well, isn't b going to be 1/4? 1/4 times 1/4 is 1/16. So if I put it together, y equals 1 times 1/4 to the x. You can write that like that. You can write it as y equals 1/4 to the x. And you could also write it as y equals 4 to the negative x power. That's all equivalent answers. Writing exponential equations.